So, I'm going to be the person that says, okay, you've now got all these nice toys, and okay, what can you do with them? Well, I'm going to say, actually, you can't play with them, because if we let you play with them, somebody might steal something, or we might lose something. So, what I'm going to do for the next 20 minutes or so is to focus on a number of things. One is, what has Etsy done in the standards? How do we make use of standards to improve security? But also, what are the underlying industry challenges we have not solved? So great, you can go out and put some of this stuff together, but actually, would you want to let it loose on the public internet? Good question, we'll explore as we go. So, when I put this together, this slide actually ended up as the conclusion slide until I thought, do you know what? Let's start with the answer to the presentation and then work out how we arrive at the answer to this. So this is the paradox for NFV. It provides the opportunity to secure networks in ways in which they historically haven't been. So if we think back to 1970 C7, there is no security on those legacy networks. It is largely either security by obscurity or simply due to the fact you have to be a fairly large entity and a member of the club to ever get anywhere near the network. Similarly, some of those nice old legacy protocols like X25, the hackers go, well, where's my IP address for this? They're ironically secure by the lack of security and obscurity. What NFV really does from a security perspective is opens it up to the world. Now, it brings us the opportunity to raise the bar, but it increases the threat surface considerably. So let's start with some very simple basics on where we are today. Can you deploy virtualized networks securely? The answer is yes. However, could you deploy a full telecoms network end-to-end the entire lot securely? My view is probably not, for reasons we'll look at as we go through this, or at least not without making some very nasty restrictions on the way in which you deploy it. Now, can we fix them, as it says on the slide? Absolutely yes. Now, hopefully, at the end of this sort of 20 minutes, you're going to think, right, this is what I need to do in my companies, my groups, and the wider industry to fix some of these. So a lot of this is the aid memoir to write, how do we take this forward? So there was your conclusion. The remaining slides are largely, how do we get to that point? Now, as others have said, please download these, because I'm going to skip a couple of them, including the what is NFV-SEC, what does it do, and how does it arrive? I noticed Don Clark's at the back of the room. Igor spent a long, long time putting this together, so please read it, the chair of NFV-SEC. But I'm not going to do it. So, as I've said, NFV gives you the power to do distributed security in ways that we could not do. The ability to monitor every single point in the network in parallel. There we go. We've actually got a security warning, which is ironically good for a security presentation. But there is your point. Even the presentation's not secure. Thank you for bringing that one up. So, it gives you some interesting capabilities, and it gives you some interesting weaknesses. Now, automation's a great thing. Not from a security perspective, it isn't, because the more you automate, the less control you have over where your resources are, how they're placed. The real Trojan horse and double-edged sword in this is the hypervisor. It gives us the ability to do all sorts of things with the network, run all these nice VNFs on a common platform. However, it also has the ability to look at everything. It controls everything. The hypervisor effectively is your single security point of failure. Compromise that, you compromise the network. However, it also has the ability to police functions in ways that we couldn't. So, as I've said, you win some, you lose some, and we'll look at where we get to. So, back in, actually it was around about 2013, 2014, some of this was done. So this is early stage 1 NFV. The security group said, well, okay, what is the fundamental problem statement that we're trying to solve for security and virtualization? And this, or a slightly modified form, it's evolved a bit, and this is the 2018 variant. What is it that we need to secure in a virtualized network in order to do stuff properly? And we'll take a little go through some of these because they overlap with some of the other presentations you've just had on APIs, creating stuff, putting things in certain places. You then get the, okay, now how do we do that securely? So let's consider topology validation and enforcement. Consider something like a TV broadcast. So football match, going out, baseball finals, whatever they're going to be if you're in America. The place your network functions exist and where your data is matters. So we've got used to saying, well, cloud services, we can just throw stuff all over the network. We can throw it anywhere in the world, and that's fine. Actually, if you want to do things securely, you do actually need to know where your network functions are. You do need to know how the network has overlaid, let's say at the 3GPP level, onto those physical data centers. You do need to know where people are accessing those virtual resources from, and also where they were 30 minutes ago when you got hacked, so you can work out where they came, or the attacker came from. That is surprisingly difficult to do. Virtual cloud functions don't like you working that out. Availability of management and support infrastructure. There are a number of interfaces on the NFV platform. Were they to ever go down or be compromised, you would lose the network. A legacy network, somebody hacks an edge firewall box, we can design them to be resilient. If you take out the orchestrator, one of the API interfaces on the core NFV platform, or I can overload it, you lose the network. That is a fundamental single point of failure change. So how do you guarantee those are securely available? Secured boot. I won't dwell on that one too much, but secure crash is more interesting. So in the early versions of NFV, both in ETSI and in other standards groups, it became apparent that crash was something that people didn't really want to talk about. Software doesn't crash, does it? What I'm more interested in from a security perspective is to say, well, okay, software does crash. But where does it crash? How does it crash? When your VNF decides to have a rather unreliable 5 minutes, where does it leave its data? What does it leave behind? If stuff is swapped out to disk, for example, where does that end up? Can you account for all of the parts of your VNF when that server and that memory space is reallocated to some other process, that other process has now not got access to that data that was left behind? Think of European GDPR. If you've sprayed personal data and other sensitive information or the root crypto keys for certain network functions around and that VNF crashes, where do those keys end up? How do you guarantee when the hypervisor reallocates things that they are now, that memory's now not been taken, or that disk resource, by something you really wouldn't want to have access to them? Performance isolation, I'll let Pierre cover that in test, but there is a security aspect to this. Time, really difficult one to do. From a security perspective, we want to know about time. We want to be able to log where did stuff happen, where did things occur. The problem with virtualization is time is very, very difficult to attest. Time is something that is shall we say, something affected by load. Time in virtualized systems is given also up by the hardware, but a VM doesn't actually have a concept of time. If the hypervisor slows time down by 50%, it's actually quite difficult for a virtual machine to work out it's got slower. Again, from a security perspective, that's not a good thing. Private keys. Now, and we'll look on one of the later slides, all keys need to be in some form of secured hardware. The problem with secured hardware is it's designed not to allow you to take keys out and put them in other places. One of the things we want to be able to do with virtual network functions is move them from one place to another. How do you do that when you can't move the root keys? An interesting problem. Multi-administrator isolation. There we go, got there eventually. Another chunk of the topic we'll have a look at. So these are the set of things that if we wish to do virtualization, telecoms securely, that we have to solve. Some of them we have, some of them we haven't. It's also worth noting that, assuming the microphone still picks me up as I wander, the stuff in the pink is effectively the threats that occurred pre-virtualization. So these are the 3GPP threats. They are the external things that are relevant to the interfaces. What NFV does is then introduce a load more, and then the hypervisor introduces some. The reason the diagram shows it hollowed out is the hypervisor both introduces threats and takes some away. Again, doesn't matter too much. So, the hypervisor, that thing that we require to make all of the NFV work and give you all of that generic resources. One of the things that we try to do with telecoms networks is to segregate them out into layers of trust. So let's consider a 3GPP network, the master root crypto function called the AUC. Whether we like it or we don't, there are probably 5 people in a network like BT that have access to the AUC. That is it. We do not let the general network administrators anywhere near the AUC because it contains the root network crypto key. Were you to ever compromise that function, you compromise the whole network. However, if we wish to virtualize the network, the AUC is going to have to get virtualized. That makes the content of the AUC visible to the hypervisor. So the question is, how do you trust the hypervisor, or how do you prevent the hypervisor seeing certain things? There's also probably a need to do that to have specialist hardware. NFV, we kind of think, well, okay, we want all this generic commodity hardware. If you are to do it securely, certain things like the root crypto centers are going to require something special. Whoops. So, as I've said, the problem statement is actually quite old, and this is some of the stuff we've made progress on, some of the stuff we haven't. So, if you are to implement a full network, we are going to have to get over the multi-domain security problem. You cannot have a single root of trust in a telecoms network and expect it to survive. If the firewalls on the edge that defend the network that you've virtualized are in the same security administration domain as the things they are protecting, and by the nature of NFV, that's what you want to do if you want to have this big software cloud resource. If you were to compromise the firewall, you will compromise the center of the network. Compare that to a legacy network where if you compromise the firewall, you can get in at the edge, but you've not compromised everything in the middle. So we need to be able to do that. The other thing that's worth taking away, and I'm not going to go through all these in the interest of time in detail, is we're frequently asked, well, okay, NFV-SEC, the security group, talks about sensitive functions. So the AUC, the root crypto center, is a sensitive function. However, it's worth noting that about 85% of 3GPP network functions would be considered sensitive. So anything that's got personal data, billing, security keys, any form of cryptography, in fact, is going to fall into the category of sensitive. So your ability to say, well, okay, it's just a few VMs, a few VNFs we have to worry about. Actually, kind of not true. So what's Etsy doing? And I've tried to limit the amount of stuff I'm going to do where I'm going to actually focus on individual specs. However, if we can do nothing else as the industry, SEC 012 is a good start point. It is insufficient, arguably, to do telecoms grade, effectively critical national infrastructure security, but if you did all of the things in that, it's a very good start. But it requires you to do more than certainly most of the proofs of concept that are around do. Security monitoring. Again, great specification that allows you to effectively do distributed monitoring throughout your network. Very, very powerful. The downside is, and here's the paradox, if the security monitoring is able to monitor everything in the network, it's also quite difficult to implement the network securely. Remote attestation. How do we attest that a particular VNF is where you want it to run? And that is attesting all the way up from the hardware through to the 3GPP or similar application layer. The thing to remember, I think, with security and virtualization is that you cannot treat the security in layers. It's not good enough to just secure the platform, secure the NFV layer in the middle, and secure the applications. You do have to bind the three together. And that's actually more difficult than it seems. We've also been looking quite closely, and you saw this in relation to IFA 26, security of the Mano interfaces, and also policy management. So, also, what else have we done in terms of where do we have to close the gaps? NFV Sec 19 is an attempt to say to the industry, well, okay, there are some big holes, we're going to document some of them. To some degree, NFV Sec 19 will be a guide to how do you hack an NFV implementation, but it is also intended to say to the industry, and now this is how you fix it. At the end of the day, there are certain things that need to be improved. That's how we do it. As I've said, time, NFV Sec 16 is worth reading if you want to understand why time is so difficult in a virtualized environment and why it is important. Have a read of that one. So, this is the POC challenge for vendors and others who like building stuff is, and again, please download the slides. I'll get you to read it from that. How would we do a secure implementation? What are the things you need to do? And the answer is you need to be able to implement this lot, and more specifically, the stuff that's on this slide. So, you need to be able to implement hardware-mediated enclaves. Things like Intel SGX go a fair way to doing this, but they don't give you everything. You also need to be able to protect against this lot, and more specifically, if you want to look at it in a process term, the necessary capabilities. Some of those are easy to do with existing software and hardware deployments that will probably be in the trade show later in the week. Some of them require capabilities that probably don't exist in the current rollouts. But this is the list. If you wanted to deploy what we would term a critical national infrastructure network, so something that has to resist a decent level of hack and threat, and that is the nature of the telecoms networks, then that is what you would have to meet to do that. So what are we really trying to do with this? And what we're really trying to achieve is this lot in simplified form. The Etsy specs try to go through how do you build this up, how do you put it together. But it's important to understand security has to encompass all of that. You cannot deal with it piecemeal. So the other thing to take away is, unlike some of the other specifications, security is always a moving target. The factor spec said, do you know what, if I do this today, my network is secure. With security, we're never going to achieve that. So the idea is the methodology. secure by design, secure by default. How do you build your products with security intrinsically built into them? And as I've said, NFV, follow the Etsy specs. You get benefits from it, but there are also the downsides. So I will finish, as always, with the more information slides. All of the security specs are available on the website. Please download them, please read them. And as I said, the presentation has a bit more information in it than I've gone through, and obviously available for questions either here or afterwards. So Thin, I think we're at time. Pretty much spot on. Thank you.
You have 3 extra minutes. So
Oh dear.
why is this interesting? Any question for security? Yes.
Great presentation, Mark Fuzinski from Akamai. So why do the...
Can you speak up a little bit?
I'm hoping you can just answer this one really quickly. Why do the big cloud providers that host all the same stuff not have the same set of problems, such that you're taking our toys away, but
Yes.
I can play with the toys over there?
So this is one of the ironies of virtualization. So I would argue one of the reasons the cloud providers have proved relatively secure is because of the nature of the hardware telecoms network and the internet infrastructure around them. So what NFV is doing is taking that surround of the cloud service providers, the telecom access networks and other infrastructure, and virtualizing them. Ironically, if you look at most cloud providers, what they tend to do is put physical hardware firewalls around their cloud servers. They don't virtualize the edge. Similarly, the telecoms network is about to start considering using the same hypervisors, the same virtualization technology as the cloud service providers. Historically, they've been different. So to get to the cloud service, you have to hack through the telecoms network. What we're doing is saying, well, actually, we want to make it all the same. So as a hacker, the really great thing with NFV is, if I can manage to hack one box of one service provider, since it's probably all using the same open source, I can now use the same hack to hack everything else. And I think that's the paradox shift.
So maybe we should rush to be cloud native. That's my question.
So yeah, as I've said, all of this is fairly solvable by some hardware and software changes here and there. And certainly my view standing at the front is at the moment you can deploy this stuff perfectly well, but it does still require a few hardware firewalls in it in order to give you some degree of, call it trust domain separation. So you have your group of functions and your group of things within a domain, but at the moment you would still probably want to put physical hardware in the way to separate certain things out. Solve some of the hypervisor type issues and some of the isolation in software, you virtualize the firewalls as well. There's kind of a role for both at the moment. I guess you've got to learn to ride a bike with stabilizers before you go for the without.
Okay. Thank you, Alex. All right.